When programming our own code, we could potentially deal with errors without using the exception mechanism. For example, we could try to use an if statement to handle various error conditions. So this would force us to write methods that return success codes, like this result over here, which basically reports potential errors like error code A or error code B, and also the code that indicates that there are no errors detected. However, this if-else approach to handle error codes brings the whole set of disadvantages, such as the code that detects the error may not sometimes be able to handle it. Basically, this method could be called from another method, which is in its own turn called from another method, which brings us to the situation that at this level, where this if statement is trying to make a decision about all these error codes, the code here, this part of our program, may not have enough information to properly handle the problems that are taking place. So secondarily, because of large number of error-related ifs will easily obscure the code. Because of this constant error checking, the if-else construct to check for error codes would have to take place after each method call, one after another, one after another. This makes a potential for a program which is difficult to understand and difficult to maintain and document. And even its own set of logical problems could be added here if these conditions checked by our if statements become more complicated. So Java exception mechanism provides an alternative object-oriented alternative to the if-else approach of checking the error codes. When Java runtime environment detects an error, which may be well beyond the control of our own program. For example, potentially we have this situation where we're trying to divide by 0 because the user entered incorrect parameters. Or we may not be able to open a file because it was deleted by somebody. In many such cases, Java runtime environment creates the exception object for us and starts the process of searching for exception handler, which is called exception propagation mechanism. Because of this large variety of different types of errors that may be taking place, Java provides a number of exception classes to specify common exceptions such as division by 0, invalid input formats, file problems. So when division by 0 exception is detected, the runtime environment creates an object of type arithmetic exception. Likewise, when the scanner object attempts to try to process the input and fails to convert some string to an integer, it generates this input mismatch exception. Both of these are examples of runtime exceptions. Exception classes form a hierarchy in Java library, and the exception class, directly or indirectly, is the superclass of all exception classes in Java. I try to gather here all these try, catch, and finally rules that we already kind of tried to walk through in our example. But in summary, the finally block is executed after the successful execution of the try block, or after one of the catch blocks has finished handling the exception. It is therefore a good practice to implement any cleanup logic inside the finally block, like for example closing a network connection, closing a file, or an input stream. Some more rules for you to read, and I don't expect you to memorize every little detail. I am sure you will gain more confidence in those rules as you gain more experience writing real-world programs. I'm sure you will actually appreciate that all these rules exist for you because they make your programming code safer and easier to structure. We can have multiple catch blocks in our try statements. And in case of multiple catch blocks, the heading of every catch block specifies the type of exception that it intends to handle. Like this one is dealing with arithmetic exception and not the other types. So catch block can catch either an exception of a specific type or an exception of a subclass of that specific type of exception according to Java exception hierarchy, or any exception if it just specifies the exception, because this is the superclass for every single exception in Java exception class hierarchy. So in a sequence of catch blocks, if we have multiple catch blocks, a catch block declaring an exception of a subclass type should be placed before any catch blocks declaring the exceptions of a superclass. So when putting together multiple catch statements, we have to distinguish which one's supposed to be placed earlier in the sequence of catch blocks compared to others with respect to exception hierarchy. I have an example of Java exception hierarchy on the next slide, but I'd like to open it right now just to show you side by side that the exception class in Java language package is the superclass, the base class for all other exceptions. And as we discussed, this arithmetic exception example is right here. It's a subclass of the runtime exception, which of course in its own turn is a subclass of exception. So because of this organization, a catch block that is using exception type will be able to catch all exceptions. And as such, it has to be placed last in the sequence of these catch blocks in a try statement with multiple catch blocks of exception handling. And the finally block is optional, but if it's present, it follows all other catch blocks at the end of the try statement.